Hi, science students. Welcome back. Today we're going to focus on atomic structure and Bohr models. So we're going to start up here, and if you need to pause the video to write these things down because you will need them as reference, go ahead and do so. So we're going to start with oxygen, and we're going to decipher what each of these parts within this little element box here represent. Let's start with oxygen. This is probably the most recognizable one to us, and this is going to be our element name. When we write out the symbol for oxygen, it's going to be the letter O. And so that letter O that we see in the box is going to be called our element symbol. The little number 8 above the O is going to be called the atomic number. And our atomic number represents how many protons or how many electrons exist in this type of atom. So anytime that I have an oxygen atom, I should expect that there are 8 protons in the nucleus or 8 electrons in those shells around the nucleus. And that's what makes oxygen oxygen. And so this number at the bottom, 15.999, is going to be our atomic mass. Typically, the atomic mass is going to be a larger number than the atomic number is going to be because of what this represents. So the atomic mass is going to be the number of neutrons in the nucleus plus the number of protons added together to create that mass number. So I want us to jump over to these two comprehension questions here. The first one says, what two parts of an atom does the atomic number represent? And so our atomic number here, that little 8, if you remember back just a second ago, I told you that the atomic number represents the number of protons or positively charged particles in the nucleus, or the number of electrons, the negatively charged particles that are floating around in those shells outside of the nucleus, racing around in their shells. So our atomic number, that number at the top, is going to be either the number of protons or the number of electrons. How do you figure out the number of neutrons, though? So if we think back and we talk about this atomic mass, this number here, atomic mass is going to be our protons plus our neutrons. So I'm going to draw a little arrow right here and remind myself of that. My atomic mass is going to be protons plus neutrons. So every time I look at a symbol like this and I see this number down here, I know that if I'm looking for the number of neutrons, all I need to do is I need to take that atomic mass and subtract the atomic number, subtract the number of protons. Because if I take out the number of protons, now all that I'm left with is the number of neutrons available. So I'm going to, on this line here, to remind myself, I'm going to write subtract the atomic number from the atomic mass. So let's talk about a couple examples. Let's talk about carbon first. If at any point you need to pause the video because I'm moving too quick for you, please do so. So I see carbon, the element symbol, I see the element name, I see a 6 and a 12.011. So I'm going to start with the number of protons. That's what number P means. And so I'm going to look at this symbol and think about, how do I know the number of protons? I can look back at my notes and say, okay, number of protons is the atomic number, that number at the top. So I can put a 6 here for that. How do I know the number of electrons? I can see electrons is also the atomic number 6. And I know to get neutrons, I need to subtract the atomic number from the atomic mass. So all I'm going to do is I'm going to take that 12.011 and subtract the atomic number 6, and I'm going to get 12.011 minus 6 equals 6.011. If we were rounding, we would round this to 6. So let's go on to neon. I see neon here. I see its atomic number, its atomic mass, and so I know that my protons and my electrons are going to be the same number. They're going to be that atomic number 10. So then to get my neutrons, all I need to do is do some subtraction. So 20.179 minus my atomic number 10 equals 10.179. All right, so we're going to do one more as practice together, potassium. Potassium has an atomic number of 19 and an atomic mass of 39.098. So I know protons and electrons are the same number, 19, and that my atomic mass, 39.098, can subtract that atomic number to get the number of neutrons. So 39.098 minus 19 equals 20.098. So now you should be able to look at any element and figure out what its atomic number, its atomic mass, and how many of each subatomic particle that you can see in that particular element that you're looking at. Pause the video here if you need to write anything down. So let's keep going. So now we're going to talk about Bohr models. Bohr models are those circular models of atoms where you can see the electrons on the outside and you can see the protons on the inside. We drew some examples of this into our notebook, but we're going to do a couple of these together. So let's talk about our arrangement of our electrons when we draw these kinds of models. The first energy level, or the first shell, is going to have 2 electrons in it. Once it's got its 2 in that shell, no more can fit there. So it has to go on to a second energy level, or a second shell of electrons, and those are going to be called our valence electrons as they're moving around in the outermost energy level. Sometimes that'll be a second ring, sometimes that'll be up to a third ring. And so our second energy level can hold up to 8 electrons, and then it becomes full. So then we have to go on to our next ring. Our next ring can hold up to 18 electrons. And so over here we have this question: what term is used to describe the electrons in the outermost energy level? This means whatever the outside ring is, whether that's the second ring or the third ring or the fifth ring, it's always going to be the outside or outermost ring is going to be called the valence. And so our valence electrons are going to be that outermost energy level, valence electrons. So let's do a couple examples together. And so this first one gives you some specific things to draw, and it tells you where to draw them. So this is really helpful in having a couple models to practice with. So I'm going to grab a couple colors so it's a little easier to distinguish these atoms from each other. And I'm going to move my camera a little bit closer so it's easier to see. So this first one, and what I want you to draw into your notebook, is the picture of the atom, as well as the instructions of what needed to go on each ring. So if you need to pause the video to write this part down, please do so. So this first part says to draw 5 protons in the nucleus and label with the charge. So I'm going to do this by just writing little plus signs and drawing 1, 2, 3, 4, 5 protons, and I've drawn them in this green kind of color. Next, it says, and I'm going to label it here, sorry. Next, it says draw neutrons in the nucleus and label with their charge. We know that neutrons are neutrally charged, so they don't have a positive or a negative charge. So it says to draw 6 of them, and I'm going to draw them by creating a little letter N and then just putting that in a circle. So I've got 1, 2, 3, 4, 5, 6 neutrons in my nucleus. And I'm just going to draw a ring or a circle around where the nucleus is. This is my nucleus. So the next thing says draw 2 electrons in the first energy level. And so the first energy level is just going to be the first ring closest to the nucleus. Notice that my rings are not perfect circles, but that I can tell that this is distinguishably different than where the nucleus is. So I'm going to use a blue pen to represent my electrons, and I'm going to label their charge as a negative sign. So I'm going to put 2 electrons in the first ring, and I'm going to draw them opposite from each other. The next instruction says draw 3 electrons in the second energy level and label with their charge. So I'm going to draw another circle, another ring or electron shell, and it says to draw 3 electrons here. So here's 1, 2, 3 electrons. And so, like what we talked about at the beginning, I should be able to figure out what element this is. How might I do that? I know that I can figure out what the element is based on the number of protons or the number of electrons. So I'm going to count up how many protons I have. 1, 2, 3, 4, 5. And I'm going to look at my handy dandy periodic table. I know that my atomic number, the number above the element symbol, is going to be the atomic number of that element. So if I have 5 protons, I know that I'm going to look for 5 as my atomic number. And the atomic number 5 is attached to the element boron, because boron has 5 protons and 5 electrons. So all I need to write down here is the name of the element. I can also put the symbol, the letter B, for boron. So to recap, all I did was look at how many protons or how many electrons it had. That's going to tell me its atomic number. And when I did that, I then went to my periodic table and looked for the atomic number 5. Let's do one more of these as a sample. So I'm going to zoom you in again, get you a little closer. So this one says draw 3 protons and label them with their charge. So again, I'm going to use my teal pen and I'm going to draw a little plus sign. 1, 2, 3 of those. I'm going to draw 4 neutrons, and I'm going to do them the same way I did the last one. 1, 2, 3, 4. I'll draw a circle around to make my nucleus. And then it says draw 2 electrons in the first shell. So here's my negative charge. I'm drawing my electron shell around. And I've got 1, 2. So I know that this shell is full. And then it says draw 1 more shell and add 1 electron. So I'm going to add 1 electron here. So I can see I have 1, 2, 3 electrons, and I have 1, 2, 3 protons. So I know that my atomic number is 3. So I can go to my periodic table and I can find the atomic number 3 for lithium. I want to return to my paper and write the element name and element symbol. The valence electrons and the nucleus should be able to tell us what our atomic number is in a Bohr diagram, which should us allow to figure out what the element is that we're looking at. That's everything I have for you today. If you need to pause the video, please do so. If not, have a really great day. Bye-bye.